Okay, this one is going to be, this theorem is tangent and the radius. So for a tangent and the radius, and I'm going to try and squeeze it in this little spot I have for notes, the tangent meets the radius always at a right angle. So if they meet at a right angle, that means you're going to use Pythagorean theorem. Which is a squared plus b squared equals c squared. And then for this figure right here, your c is always the hypotenuse. So it's always the side that's across from the right angle. And it would be the entire thing right here. That whole thing would be C. Your A, your B. Okay, and I'm going to do an example on the next sheet of paper. So for my example, my question is, what is the value of x? And typically when they have these problems, they'll say, if the line appears to be tangent, it is tangent. So you can assume that this line is tangent. Didn't do a great job of drawing this one either, unfortunately. There we go. Okay, so this guy should be the right angle right here. And I'm going to give you that we're looking for the radius. The hypotenuse right here is 19.2. And then the side of it is equal to 12. So when you solve this, the part that's inside the circle, that goes inside the circle, that's not really your right angle. I know it appears to be a right angle from my picture. That's just the way I drew it. I didn't do a very good job. This is your right angle. So this would be your C. Your A or your B does not matter. And then your B. Trying to do quotes right there, but it was messed up. I'm going to just cross that off and say that's your A. Okay, so we're going to plug it in. X squared plus 12 squared equals 19.2 squared. 12 times 12, 144. 19.2 times 19.2 is 368.64. Subtract 144 from both sides. Bring down the x squared. I get, when you subtract those two numbers, 224.64. Square root both sides. And for that, I get 14.9 or about 15. If we rounded to the 10th or to the whole number, we would get 15. So I'm going to say 15. Okay, so that was for not two tangents. That was for the tangent and the radius. Now we're going to get into the, I'm going to do the secant and the tangent first. So this might have not been the way that we learned them, the order that we learned them in class, but that's okay. Okay, so the secant and the tangent, remember that a secant goes inside the circle and outside. So the part that's inside is known as the chord, and then it just keeps going. And then the tangent does not go inside the circle. I don't know if you can hear Pythagoras, but he just ran down the stairs. He's got a lot of energy. Okay, and this is the theorem. It basically says, he's running back up the stairs. It basically says that in order to solve for a missing side, you take the outside part times the entire length equals the outside part times the entire length. And when you have a tangent in the problem, the entire length is the outside part. So you do c times c or c squared. That's how you would do that problem. So let's do an example. So we have drawing very large circles. X on the inside, 8 on the outside for the secant. And then I've got 10 for the tangent. How would you set this up? Well, I see that my whole thing here is 10, so I'm good there. You would do 10 times 10. And then I see for this part, my whole thing is x plus 8. So I'm going to have to do 8 times x plus 8. And I always try and simplify the inside if I can. I can't in this problem because there's a variable. Equals, and then you would do 10 times 10. Because the outside part is the whole thing. Okay, and now we're going to distribute. We get 8x plus 8 times 8 is 64. 10 times 10 is 100 minus 64. We get, drop down the 8x. Hi, Pi. Are you crying because you're not getting enough attention? You want to do this problem? He's just staring at me now. Divide by 8. Yeah. Are you going to come up here and ruin things? I hope you guys can hear him. Otherwise, I'm just talking to myself. Oh, good job, Pi. He jumped on the table. 36 divided by 8, and we get 4.5. Oh, here's Pi. He's going to come and ruin the shot. Good job, buddy. Ignore the cat. Let's go to almost our final example. We've got 2 more. This one is done very similarly. It's the secant to secant problem. Okay, so if we have 2 secants, we just have to do outside times whole on both sides. So I'm going to go to the other side, which is kind of backwards. Oh, there's Pi again. You can see his tail. Okay, so for this example, I'm going to just give you the property. Okay, thank you, Pi. I'm going to try and do this while holding him. A, B, C, D. So we would do the outside part times the whole thing. Again, you add them. Outside part times the whole thing. Okay. For the example, it's going to be the same type of problem. I'm going to make my point right up here. I'm going to connect, and I'm going to connect it to two parts of the circle. Outside on the left, secant is 11. The inside part is going to be x. Inside part here is 8. And then the outside part is 9. And we're going to go ahead, add them if you can. X and 11 can't add, so you're going to have it be x plus 11. As soon as I do that, I'm going to write it down. So we did the outside times the whole thing. Now I'm going to go to the other side and do the same thing. 8 and 9, you can add those. 8 plus 9 is 17. And so now I'm going to use 9 times 17. If you wanted to write it out like we did the last time, that's perfectly fine. Just remember to simplify because that will make your life easier. Distribute the 11 and multiply 9 and 17. Get 121 when you do 11 times 11. 9 times 17 is 153. And now we're just solving for x. Subtract 121 on both sides. I'm running out of space. I'm going to come up here. We get 11x equals 32. Divide by 11, I get x equals 2.9 about. I wanted to try and get everything on 2 pages, but I'm going to have to go to page number 3. Just for this last example. Last example is 2 chords. I think this honestly was like the third thing we learned, but we're going to cover it last. So super easy, 2 chords. It's easy to mess up too. So you can see this problem. Oh, it's not that bad. You got to be careful. When you have 2 chords that intersect, you do the parts of one chord, multiply together, so their products equals the products of the other 2 parts for your chord, for your second chord. So in this case, A and B make up the first chord, or I'm going to call it the first chord. Multiply them together. C and D make up your second chord. Multiply them together. Not too difficult. Here is the example. I'm going to call that X. My chord kind of got messed up. 5, 6, and 4. Okay, so you want to figure out which chord is which. So this is one chord. I'm going to do 5 times X. This is the other chord. I'm going to do 4 times 6. 4 times 6 is 24. Divide by 5. You get x equals 4.8. And that is it. That's the circle theorems for today, which is quite a bit. And these are every single problem that you're going to see on the Segments and Circles worksheet.